haven't hit it already, still working, I'm still learning, I'm still searching, finally earning something, finally turning something called a profit. If I hear you talking shit, don't get caught in it. I'll be popping off and hit your ass, dropping all your shit. Yeah, I promise this, I got promises, you ain't stopping this. Cross my shit, you'll be knocked unconscious, bitch. That's the consequence, I got this, I will not quit. Man, I'm on it, honest, I'm gonna launch quick, then I'm gone. It's just a matter of time before I'm over the climb and moving under my prime. Just quit my 9 to 5, I'm rocking, and they watching, cause it's shocking. Dropping all these top 10 songs, so stopping. It's time to live my life, it's time to live, not die. Wish I could slow down time and just enjoy the climb.
What is up, people? So we're gonna get this in. Let me go ahead and make sure that's going. So, as the title says, I wanted to get into this atmospheric issues that we have. Yes, inspired by my boy Chris in the chat. He had been coming across with a few ideas, thinking, you know, what the hypothesis will say. That that basically things that we are observing and assuming to be seeing is all due to atmosphere. Now, obviously, I agree. I don't agree with what he's saying, only in the fact that there's a lot of variables that aren't exactly gonna work. And I want to go through it. So let's see here. So we've got that up and running. It's good to go. What's up, sir? How you doing?
What up?
So I know damn well you wanted to get into this conversation.
That's damn right.
Yes, right. So one of the things that I don't think... before we get too ahead of ourselves... Do you want to explain what your observations or what you're trying to show through atmosphere?
Well, we have claims, right? We have claims of obstruction due to something. So we have some people saying we have obstruction mostly from the bottom up due to curvature, and we have people saying we have obstruction from the bottom up due to some sort of atmospherics, be it magnification, be it refraction, right? Some sort of inferior mirage. So my whole argument is, well, we know that those atmospheric conditions exist for sure, without a doubt, 100% fact. What we don't know exists is the curvature. So we can definitely explain obstruction via atmospherics, but I have yet to see obstruction due to curvature just pure by itself.
Well, obstruction due to curvature, what do you mean when you say we don't see? Because
so we see obstruction, right?
Mm-hmm.
Then the question is, what's causing the obstruction? That's the caveat.
Well, wouldn't the globe's curve be an answer for obstruction, though?
It could be an answer. It's a theoretical answer. But we don't know if that exists or not, right? We're trying to figure that out. What we do know exists is atmospheric conditions that can cause obstruction from the bottom up.
That is very true. There are many atmospheric conditions that would do this. So, you know, obviously before I did kind of called you out without calling you out. I did a lot of researching on this topic, and on top of the things that I assumed I already knew. I think I'd already said it before. You know, I didn't really know too much about the refractions and all that stuff. I have a basic understanding now, but again, the things that are seen still don't work, and I'm not going to go into why I know they don't work yet. But
Wait. You said the things that are seen don't work? What do you mean by that?
So, for instance, when we're standing at the beach and we're observing a boat heading away from us, I would say it would appear to be going over the curve, and you would say that atmosphere is the reason for it.
That's right.
Okay, so here's the reason it doesn't work. Now, we've discussed, I mean, I've heard you say it, and I've repeated it. There are insane amount of atmospheric conditions that can play a factor in these things, right?
Correct.
Okay, so I'm not sure if you can see the YouTube page. I'm going to actually pull up one of a couple of images that I have. Or actually, they're actually already on there. So there's things like mirages. That's obviously, damn, I keep hitting the mic. A lot of people already know is basically, that glossy, mirrory look on the road when you're driving down the road and it's hot as hell, right? We agree, right, Chris?
Yeah, sure.
Okay. I just want to get a good rundown so we're on the same page. And what I'm naming now are the basic atmospheric conditions. There are things that, play into factors other than, but there's haze, pollution. There's mist. There's, what else is there? There's damn, I had everything in my head. That's all gone. Mist, smoke,
fog, clouds,
yes. I mean, you name it. Now,
right.
The reason I say this is because with each one of those atmospheric conditions, your observation changes, correct? So if we're looking at something in each one of those conditions, we're not going to have the same observation.
I mean, it depends on what you mean by that. Are you saying same time, same location, or different time, different location?
So we're standing at the beach watching this boat take off.
Right.
And for the sake of the argument, we'll change the variables like that. Just, one day, it's one situation, it's each one of those conditions. What would we see?
Okay. Yeah, you will see different phenomena. You might see a different horizon of what's called an apparent horizon line. Okay. You'll be able to see further. You'll be able to see, not as far, depending on those conditions. Yes.
Okay. So once we get to that situation, now we've added the variables to it. We know exactly what we're trying to figure out. Now, if let's say it's a foggy day, what would our observation is basically going to be a boat disappearing into the fog, right?
On a foggy day?
Yeah. Sure. Okay, and then on a say on a hazy day, what would we observe?
Well, I guess you're going to say that the boat disappearing into the haze.
Well, no, because the haze isn't blocking out our observation. It's just hazy. So I'm thinking we'll see the same. We'll see the boat disappear, bottom up, but we probably won't be able to see so much detail of the boat because it's hazy.
Sure.
Okay. Now, let's think, now it's a perfectly clear day. Both our observations are going to show that boat disappearing from bottom to top.
Okay, so let's just stop right there. Okay, let's come to terms, because I hear people say, well, this image is clear on a perfect day and this one isn't. There is no such thing as a perfectly clear day.
You are 100% right.
There's always atmosphere. Mm-hmm. There's always conditions that will cause optical phenomenon to happen. So one day might be more clear than another day.
Yes.
So you'll see further perhaps, but you still won't be able to see, say, 1,000 miles away because of the atmosphere that you're looking through. and that's going to cause those optical variations.
But when you say because of the atmosphere you can't see 1,000 miles, where do you get when or why would you assume that you would be able to see 1,000 miles?
Well, I'm saying if you could, or I'm saying one of the reasons you can't, if you could, is because of the atmosphere.
Well, I think it'd be more important to say that we can't see that far because of other factors, don't you think?
Well, what other factors?
Let me see here. Looking through the little notes. And I'm pretty sure there are people out there that know it, but let's do it on my turn, on my speed, because when I do it this way, I feel like I'm learning.
Yeah, so let me say two.
Go ahead.
There's two main while you're looking through your notes. There's two main things that I would say are the cause of not seeing to a certain distance. So in other words, when someone says, "Why can't I see, China, or I can't see London from where I am," or some stupid thing like that. Well, there's two main reasons. One is perspective. As you get further from something, the perspective changes, the angular size changes, so things appear to get smaller. I mean, we know they're not actually shrinking in size. They appear to shrink in size. So at some point, they're going to go beyond what's called that vanishing point, and you'll no longer be able to see them no matter what. On top of that, then you have atmosphere and atmospherics and optics at play that also come into effect.
When you say they disappear, or basically they disappear in their entirety, are you saying that happens in all observations, or?
Yes.
Okay. Well,
at some point, yes.
Okay. Well, the problem with that is if it was flat, then that's exactly what we would observe in all the situations.
What do you mean?
So, if it was flat and it wasn't going over a presumable curve, whether it be fog, the boat would disappear into the fog. If it was haze, the boat would disappear into the distance still. Clear day, same thing. I mean, so if it was flat,
right? So that's going towards my point.
Well, I'm just kind of clarifying it.
Okay.
The issue is that maybe fog, haze I wouldn't consider, clear day I definitely wouldn't consider it. Even a smoky day, because smoke rises and it's not going to be off on the horizon area. I would say that in all the other situations besides fog, and maybe a really bad haze at that, we see it disappearing from the bottom up, and there's no problem with that. Okay, but we don't see it disappearing in its entirety, which would be what it did if it was flat.
Why would it disappear in its entirety?
Okay, because when you describe a refraction over the water, for instance, the picture I have in the bottom left corner and on the YouTube, where it looks like the boat's not in the water, it's actually in the air, right? I
mean, it's a really small picture and it's kind of grainy, but okay.
Well, it was the image that I had in the very beginning.
Can you share it on the Hangout?
Yeah, I'll do that right now.
That'd be better.
Yeah, sorry about that. Right, so this picture right here. So this image, this is an effect. This is one of the atmospheric effects that we do encounter in a lot of observations, correct?
Sure.
Okay. Would you have this effect on a cloudy day?
I mean, I have no idea. Well, I don't know what conditions led to this effect in the first place.
No. But that's the thing. We do know. We know there's only a handful of terms or reasonings for this to happen. They are considered atmospheric phenomena, but that's not exactly true. So when we're looking at this observation right now, we can see it's a clear day. We know that we know a mirage is basically.
I have to be honest. Let me just stop you. This might be one of the worst pictures we can use to try and prove or disprove something, because it's really grainy. Those ships they just look like blobs of something, right? So I mean, I don't know what the benefit of using a picture like this would be. You say it's.
I'm not using this picture as a proof of anything. This is just
Well, you just said it's on a clear day, and when I'm looking at this, it's not clear at all.
Okay, I can find a clear one. I mean, to me, it doesn't really matter that much. I mean, it's just a visual aid. I'll get a better one. So it's a little.
Well, I don't. Yeah, I'm not trying to hinder your point. I'm just saying.
I know. I get it. You want to be thorough, and I perfectly respect that. I have no problem with that at all. Let me get this here. All right, go ahead and find this real quick. All right. Go ahead and share it. All right, so, I mean, we can basically use any of the pictures, right? I mean, it's not, let me see, put this over here. Okay, so we'll use, I mean, the only reason I really use that picture is because it was like a really good, depiction of that, how obvious that mirage is. But I get what you're saying.
Where it appears like they're floating or something?
Yeah.
I've seen those before, let me see if I can, did you find one, or?
Well, I found a few, but I'm just kind of looking for a clear one.
Okay.
All right, I'll use the one up here. We'll use...
Here, I got one.
All right, perfect. Stop share. Let me know when you're ready.
Well, here, I'll,
put it inside.
Well, let me send you the link.
Okay.
Let me see if I can get to it.
Cool.
I guess it's from a video or something.
Or here's one. I mean, either way. Let me see. See, that one's kind of grainy too, but it worked. Listen. We can use. Actually, I want to use all of these.
Go to Google image search and just type in "boat appears to float mirage," and it'll come up with a bunch.
Okay. So we'll use, it's like all the good ones are all kind of fuzzy. I'll go ahead and share it.
Like the first one's good, the second one's good, as far as I got.
The first ones I'm looking at?
Let me see.
I mean, I don't think those would work.
Type in mirage as your last word.
Okay. Perfect. Okay.
There you go.
Okay. Yeah, this is one of them that I was looking at.
So this is FEer. So let's talk about a couple of things. So obviously you've got some sort of atmospherics or optics at play with this, right? But what this also shows is there's a big contingent, or one of the contingents and points for ball Earth is, hey, I'm going to use a theodolite, or I'm going to use a telescope and point it at the horizon, and then I'm going to measure the dip angle. Okay. Well, if you were to use this particular day in this particular area, and you were to use a theodolite to measure the angle from a particular height, look how much variance you have from where that boat is, where that's actually water, right? Clear water, if you want to call it, or almost invisible, to what appears to be the horizon. So anytime someone says, I'm looking at the horizon, or I've measured the dip angle to the horizon, we have to ask, how did you know that was the actual horizon and not an apparent or miraged horizon, because we know for a fact that this can happen, and that puts a huge, wrench in that idea, basically.
So one of the factors that I kind of heard was an issue. So you said a theodolite. So if we're using a theodolite here, the theodolite actually would tell us where the horizon is, and it would be basically between the two of what you're seeing.
But what do you mean between the two?
So say the horizon is right at where the boat is, but it appears that that's not. But it appears the horizon is way under.
Right.
A theodolite's going to give us the actual. We'll know where we'll be able to calculate where the horizon actually is.
How will it do that? Aren't you pointing it to that line?
No, because it's the same thing with your elevation and distance. That you would factor in your elevation that you're shooting from, and then that would give you your number. You would know, doing the calculations, where your horizon is supposed to be, what percent. It'd be very small if you're that low, but the theodolite actually is the tool you would use to find out where that horizon actually is, based on the fact that we know where the horizon is.
But we don't know where the horizon is.
No, we do. So if you're a 6 foot tall person, we know the horizon is 3 point.
Okay, that's.
Go ahead. Let me see.
So sorry, you're getting into assumption territory,
it's
right?
It's not assumptions.
That's if we live on a sphere. Yeah, that's if we live on a sphere.
Okay, here's the thing. If I'm 6 feet tall and I can measure that horizon to be 3.5 miles away, if I go 1,000, why?
Because we can see much further than 3.5 miles away if you're 6 feet tall.
We can see further, but that doesn't mean the horizon is going to be further. The horizon.
Well, I've seen cases where it is further.
And what elevation?
Well, I don't know. I guess I don't want to get into that, but
well, I'm just saying it matters to the elevation to where your horizon is, and that's how we know where the horizon is. Because if we go to 1,000 feet, we can use a theodolite in the horizon.
Okay, so let me
go ahead.
Okay, so you've seen those videos of people taking these water levels, right? They'll have like two tubes of water in it, and it creates its own natural level, and then they put it up against what appears to be the horizon. They say, "Oh, look, the horizon's lower than the water level." Well, again, if you do that here,
wait, how do you
absolutely.
I haven't seen those videos, so how would you?
Oh, you haven't seen that?
You mean like hold it up in front of you?
Yeah, they hold it up in front of them and say, "Look, the water level is higher than the horizon, therefore the horizon has dropped." If you do it in this scenario, right? If you did it in this picture that day, well, yeah, you would have a huge drop, and you say, "Oh, look, I'm standing on 10 feet of elevation, therefore the horizon has dropped," and because my level shows that. But again, they're not taking into account these variables.
Well, if you held the level up in front of your face, the horizon isn't going to be at eye level. It's not at eye level. It's going to be higher than eye level or you're going to be taller than the horizon.
Well, the theory is that it would extend to your eye, right? No matter how tall or how high you are.
It appears to, but it doesn't.
But how do you know it doesn't?
Well, we can use the theodolite, and the theodolite will tell us the degrees in which the horizon is below us.
But you would use the theodolite to show you the degree, but then you have to look out at something to see how it compares.
Well, yeah, you can do that too. For instance, if we were using that boat, we could have that boat take off and go out. And once we started, it appeared that boat started disappearing from the bottom up. We could tailor where his mileage is, and I'm pretty sure that they've done that. That's exactly how you would do so.
But you get my point, right? It's like, even if you use the theodolite, you have to compare the degree that it's telling you that the horizon is to something. So if you were to look out through a theodolite or look in a theodolite and its optics, it would say, okay, the horizon is here. But then you would look and say, oh, look, this horizon's lower, therefore there's a dip.
Okay, no, but it doesn't work that way. So let's just say, and you're able to see, not landlocked and you're able to see three sides of the ocean. No matter which way you point, your horizon will be at the same. It will be the same, pending you don't move your elevation. Say you're in one spot. Now the issue with what you're saying is the way you're thinking. The way you calculate it is you need a physical thing to calculate. Okay, so the degrees in which, so when you're using a level, it's not going to give you the degrees up and down that you need to be for a real number. With a theodolite, it actually does that. So you would start at 0, which would be level. So as far as that theodolite's concerned, and you're adjusting, when you set up and start, you want to make sure your theodolite is level, because that is 0. Doesn't matter the elevation, because if you're at 1,000 feet, you then calculate you're at 1,000 feet. Therefore, my percentage will be this. When you're doing your calculations. So when you're saying how would you measure where anything is or how far something, it all is in relation to your elevation and that level, that theodolite is level. Because no matter what,
okay,
it's going to give you the different. Go ahead.
So I sort of took us on that tangent. Let's go back to the boat and the water and the optics.
Okay. So in the image we're looking at, the issue that I would have is, do you see that on a cloudy day?
I don't know. You could. I have no idea.
I don't believe so.
I don't think clouds or no clouds are what's causing that. It's probably some sort of temperature variation, right?
Yes,
temperature inversion or something.
Yes, it's the conversion of warm air, a warm surface or warmer surface than air temperature, creating it's like a upward pattern of the light, basically.
Right.
So on a cool day, it wouldn't do that. On a cloudy day, it's less likely to do that. Obviously, we could probably have humid days or a cloudy day with a Santa Ana. If you don't know what that is, it's a warm air that comes from the east for us in California.
Okay. Well, what's the point? So if it's cloudy or not, what are you getting at?
That boat that we're looking at now, at 3.5 miles, whether it's a mirage or no mirage, because we have just splendid atmospheric conditions, unheard of. It's going to start disappearing from the bottom up every time. Now, obviously, we already said fog. It won't, because
due to optics.
Yes. Nope. It's not due to optics, because if it was due to
it is due to optics.
Well, why is it due to optics?
It's due to perspective and refraction.
Wait, well, no, because that's due to what we're looking at right now is due to the refraction.
Right. So if that boat, so let's keep on this picture. If that boat were to sail away from us, and you're looking at it, that boat will never change its level. Okay, will never go over a curve. It will disappear eventually the farther it gets due to atmospheric particles in the way. That's what will happen. That's what I see time and time again.
Will it disappear from the bottom up, or will it disappear in its entirety?
Well, because the angle, the lower you are, the lower the angle is towards the bottom. The bottom, I would say I've seen cases where it might not even disappear first, but what it might do is sort of blend into its environment sooner and blend into that water sooner from the bottom. But then eventually everything's going to sort of blend together and look like one big chunk of something.
So what you basically described is it disappearing in a hole.
Disappearing in a hole.
Disappearing as if it were to be disappearing into fog.
Yes.
But that's not what would happen. We don't. That's not.
Yes, it is.
Can you show me a video?
Yeah, Wolfie's video. Wolfie has a video he did. Or is it Wolfie or Reds? One of those two guys has a video of a sailboat moving away, and as it gets further and further, the bottom starts to refract and reflect, and then it refracts into itself, so it mirrors itself, and then it converges because it's so far away. It looks like sort of like one piece, and then the whole boat looks like one piece. But the thing is the boat never lowers its elevation, never gets lowered. It just goes on and on and on until it disappears.
It's not going to, but okay. But when it did that, did you lose half the boat at any time?
No.
So you're saying it disappeared. So when you last saw the boat in the video, it looked like a speck. It didn't at no point in time.
It doesn't look like a speck. You can see all of the boat, but it's mushed together like a blob. And then and gradually, as it keeps going further and further away, it starts to seamlessly sort of disappear into the haze.
I would have to see it because I'm not even understanding.
Yeah,
because
I mean, if you want to pull it up, I don't know about the copyrights and all that.
I don't care about that. If they want to copyright me, I don't care. I really don't. So
let me find it, and I'll send you the link.
Okay, perfect. Okay.
It's actually, I think Jaren actually talked about it. So I usually go to Jaren's channel.
Okay. Yeah, I think you shared the video before, a part of it before somewhere. I think.
Yes. Yeah, it was probably on the Discord.
Kind of looked like I think so. It kind of looked like the boat we were looking at, but it's actually moving.
Right.
Again, and all those videos, it's not disappearing as if into a fog. They're all do still disappear from the bottom up. Now, what I see
but we can explain that. Keep in mind. Okay.
No, but here's the thing, because I noticed it was happening. Now, when I say it's happening because it's appearing to go over the curve.
Right.
You don't like when I'm presuming it's a globe. The problem is aren't you presuming it's flat?
No, I'm not presuming anything. I'm just looking at the observation and the optics.
Okay, I was just making sure because you never did say it's flat or because of it's flat. So I was clarifying.
Well, I do think it's flat, but
but you haven't used that.
At it, yes, right, correct, and I haven't needed to. So you'd say, okay, well, it's obstructed from the bottom. Why? And I'd say, well, I can see based on his many observations, not one or two videos or pictures, that things tend to disappear or refract from the bottom first, right? Because that's closer to the surface, closer to the heat and the water.
But they're not disappearing though. It's more of a mirror effect.
Correct, most of the time. But keep in mind that mirror that you see is blocking the bottom of the ship. It's mirroring the top part of the ship, so you can't see the bottom because of that mirror line. That's the thing.
But that when you may not be able to see the bottom, but we still know it's there. So we can still use the back, the I don't even know what you call it, the stern of the boat on the corner. We don't actually need the bottom of the boat, because when it mirrors, it doesn't mirror all the way up to the point where the whole thing's gone, even though it's not really there. That's not an effect that's not an effect we see. We don't ever see that image we're looking at. We don't ever see that disappear, yet we know it's still there, and it's doing that because of refraction or diffraction or any of those.
So let's look at it, and let's look at an actual video, okay, and kind of go over it together. And I just found this isn't the one I was talking about, but it looks pretty decent. Okay. I can't tell if this guy is a Poe or what, but he says, "Ship going over the curve, the flatties will hate this." Again, it's from a guy named Critical Think. I don't know if he's a baller or a flatter earther trying to trick people. I don't know, but let me share, and then we can look at it together.
Yeah. That's regardless of whether or not the person is a Poe or this or that. I mean, the observation should give us what we're looking for anyway.
Sure. Okay, so here, I guess this is a still image. So let's just look at this image and kind of see what's going on. Okay, so we have a water line here that most people would say is the horizon. Well, you and I know that that's probably, or most likely, and a lot of times, not the case. And in fact, we do know that's not the case because we can see a clear mirror line starting right about here. Okay, so from this discoloration to this blue mirrored here into this red mirrored all the way down. So actually, the real horizon would be right around here somewhere.
Yeah, okay. Right about where your cursor is, yes.
Right about where my cursor is. Also notice what I'm calling the clarity of the boat. Now, obviously, it's sort of grainy, but I mean, clarity in terms of you can see pretty much from the top to the bottom. Now, mind you, what people would say, oh, look, here's the bottom of the boat. No, you can't see the bottom of the boat. First of all, a good chunk of the boat's in the water, right? So that one always gets me. We can't see the bottom.
I'd say right where your cursor is right now would probably be the bottom.
That's okay. That's good. It's not the bottom. It's the mirrored water line of the top of the boat. Okay, you can't see the bottom because this. Look, you see, I'm going from here to here. That's all mirrored reflection and refraction, or whatever is the cause. We can't see the actual bottom of the boat. Okay, but what we can see is from here up. Okay, so we see it pretty clearly. We see blue and yellow and white and red and all this, and it's pretty clear and close. Now, as we get further and further out,
before you go further up, can you back up again? Go to about 1 minute mark.
Oh, 1 minute.
Yeah. Could we go from here?
Yeah. Okay, so let's look at this. So already we're seeing some mirroring here. You can see the angle. You see this angle here. It goes like this, but then here it takes a sharp turn here. So that's already starting the mirror line. So let's just go up a little bit. I'll just do it in chunks as slow as I can to see. So here's the mirror. You can see it here in the mirror line. So anything, again, below about this point is a refracted reflection on the water, and it's not the actual bottom of the boat. But let's keep going. Okay, so now it's getting further away, and you can see the same pivot point here. So it goes in this way, but then it goes down this way because of the mirror. Okay, so it's going. Now this is obviously zoomed in, but you see this is like look at this perfect mirror line here. Okay, from top to bottom. Okay, so again, somewhere right in here is mirror. Okay, now he's zoomed out. Okay, now he's zoomed back in. Okay, well, that's not very clear. But now look at this. So you see this yellow here? This yellow right here is a mirror of that yellow. Okay, so we know still that there's a reflection line somewhere in this area. And as the boat gets further away, so what you would expect to happen is the boat goes, right, plunks those down into the water. What happens until the end of this video is this thing just keeps going out, sort of in a sort of called a perspective angle. I mean, the ship will get smaller, but it just always is there, right? So let's just keep looking. Okay, so it's still there. Obviously, an obvious mirror line here still. Keep going. Mirror line. Let me just go up a little bit. Okay, so it's still mirrored. Mirrored. Now we can see, right? It's not quite as clear as it was. We're at 10 minutes, not quite as clear as it was at 4 minute mark. So we've had 6 minutes of movement, and now it's getting a little bit hazier to see, not quite as clear. Keeps going. Okay, now it's getting a little bit blobbier. Everything's sort of blending together. Keeps going. Oh, and now look at this, right? So even from here to here, it's just like, it's just a blobby mess. Now here's the catch. The bottom isn't missing. The whole ship is still here above this line. The problem is the mirror line here is blocking out the bottom. But notice the ship, you see this angle looks like a triangle here? That's indicative of it being on a flat surface. So you have a perfectly perspective ship here, but that's mirrored this way on the flat water.
You're seeing refraction and using it for a physical object. The problem is what you pretty much pinpointed exactly what I was saying. If you go back in the timeline and you move, if you move back in the timeline and you move yourself forward as you go, like you were, you'll notice something, that even the refraction starts from the bottom and works its way up. Now, where your cursor is right now, where you were saying that's the part of the boat, that's not the part of the boat, because what you're looking for is that mirroring line. Now,
right. So the mirror line is about here. About where my cursor is about the mirror line.
The problem is what you're seeing has nothing to do with distance, has nothing to do with atmospheric problems.
Absolutely.
No, listen. Yeah. That's just crappy photo. That's crappy video. That's not.
No, it's not right.
Wait. So you're telling me that's focused?
It's as in focus as that camera will get at that distance. So then you have to imagine this boat is very far away.
Okay, but then why isn't the water closer any better?
What do you mean?
So
closer.
That boat that is obviously further away than the water closest to us, and the lower of the video.
You're talking about this?
Lower, way lower, down by your tire.
Way lower.
Yep, right there. That water should have more clarity than the boat itself. But this whole image is blah. So the problem I'm seeing is that isn't going. You're not going to get a good calculation.
No, it's because it's zoomed in. That's why.
No, but see, hang on. Then
yeah, and zooming in.
Back up.
It does downgrade the clarity just a little bit, but that's not the problem.
Oh, okay, well, back up.
Can I just finish? Can I just finish? We're almost
okay.
To the end.
Yeah, go ahead.
So notice here, you can see kind of this triangle part, right? Now notice as the boat goes further out. Now look at the top. Okay, the top hasn't moved a bit. It's still as high as it has been the whole time, and it's got to be many, many miles further away. And not only that, but you can see it's not quite as clear. It's starting to get hazier. Now let me go just a couple more minutes in, and look. I mean, it's just being hazed out. It's going to slowly keep going. It's going to slowly fade out due to distance and due to atmosphere. And that's what I've been saying and explaining, and that's what we're dealing with.
But again, you would have to show me how you came to the conclusion that the whole boat is still visible. Because
no, I didn't say the whole boat's still visible, but the whole boat is still there, because if this is the mirrored water line, right, somewhere in this area, then we know this is the top of the water, and the boat's up in the top of the water, and the boat hasn't gone down over any hump or any curve. Like not at all, not just not a little bit, like not at all. And every 3 miles, you're talking six more feet, or every mile it's that much more. Am I thinking not linear, but exponential, right, curve? So we should have seen a drastic change. Now, if you say, well, there is some change, it is simply due to the angular size change due to perspective.
Well, for one, the biggest issue I see is the clarity, because in this video, I have no clue how you're able to see where the mirror line is.
Well, but remember, I've been establishing the mirror line since the first. Look,
yeah,
it's right here.
That's a much clearer image.
Of course, because the boat's closer and he's not. He doesn't have to zoom in quite as much.
Now, if you back out again and you start over from that video and you click as you go ahead, you'll realize that even with that refraction, the refraction still the refraction still it occupies the space from the bottom up. Word that crappy.
Right. It's why the bottom disappears, because it's behind this refracted zone.
Okay. Now here's the problem with what you're saying. If it was flat and we were having the same refraction issue, you realize that it would show that mirroring line on the part of the boat, and then everything about what we're watching right now. So we have the mirroring effect. We know that that's not the exact horizon. We would see that shrink. The refraction wouldn't take over everything, because it's not mirroring what you're looking at. So when you see the mirroring effect, it's not like you're looking at the water and it's showing your reflection. It's literally bringing up what it's refracting.
No.
Yeah, it is.
It's not. It's not bringing up. It's refracting, and it's mirroring. Say this. Look. Okay, this portion here is being mirrored to this portion here. It's not bringing anything up. It's flipped it, and it's mirrored. It's mirrored it on this part of the water that is not this dark blue.
Okay, when you look at an ocean, or when you look at the water and you see your reflection, does your reflection appear to be above the water line?
I'm not sure I'm following.
So, in the mirroring effect we're seeing, is that?
Can we use this image or not?
Yeah, it's fine. Is that image? Are you seeing a mirroring effect from the water level, or is the light that your eyes use to see that bending it? Is there two objects there, or is there actually, if we went up to that boat, would that be happening still?
No, it wouldn't.
Okay. So, and when I'm thinking that, to me, that means that first that, but how am I going to say? It wouldn't affect the object we're observing as it would if it were flat. Meaning, if it was big and, you know, close to us, and it started doing it, the refraction, as it went away, it would start getting smaller, but that refraction wouldn't stay the same size. The refraction would actually shrink with it. Whereas in what we're seeing here,
and it increases. That's right. The refracted or the mirrored part increases as the boat goes farther away.
But here's the problem. On a flat Earth, what should happen is as it shrinks, it would shrink evenly, meaning every part of it would shrink all together. The bottom wouldn't disappear, because again, we've already shown that this refraction does not make the bottom disappear. But if the light that you use for your eyes are looking at that boat, and the light isn't, or the bottom of that boat, the blue part, isn't visible to the camera, it won't pick up the refraction from that part of the boat. Why? Because it can't be seen. You don't see something that's not there. If anything, it takes away.
Why can't you see the bottom? Okay, in this picture, the boat's right. It's probably a couple miles, but it's not that far out. Why can't you see the bottom of this boat right now? It's obviously not over a curve because it's on top of the water. Right, because of refraction. Mm-hmm. Right, so you can't see the bottom because of refraction.
Okay. Now, when you go up in the timeline and you don't see any of that blue and you only see the red in the stack, that's because the bottom is too low for you to see. Or it's...
No.
Why not?
Because, no, it's mirrored. It's become mirrored.
Okay, again, so look, if it was mirrored, then we wouldn't see that. Look. We would see a smaller blue area. We would see a smaller. We would see
the refracted area has gotten larger. If you can't tell. Okay, let's go back. Okay, look. Okay, you see where here you see the mirror zone here is about here, because you can see the angle as it goes. You know, it goes like this.
Yes.
And that's a mirror of this. Okay. Mm-hmm. Look how high it is above the water, right?
Okay.
It's not that high above the water.
You know
now,
that,
if I go here,
you know that's not a
look how high.
You know that the refraction isn't a set height, right? Like it's not like all refraction is 3 feet, all refraction is 10 feet. You know that, right?
No, of course. But I'm showing you as the boat gets farther away, the refraction zone gets larger, and it takes up more. And it takes up more of this up and down space.
Okay, and so. Here's the thing, you're not realizing that what you're looking at right now is actually playing to what I'm saying to you. The reason you don't see...
No, because what you haven't said is curve. You haven't said the boat's going over the curve. That's the problem. We have a boat that's here that's a couple miles, and by the end it's many, many more miles, and it's not gone over any curve. It's still on a flat surface. Look, you can see it's on a flat surface.
That is a boat. That is, we're seeing the effects of refraction in that image. Yes. Problem is,
and that's what
you're not taking into account is the fact that half of that boat isn't being refracted right now.
It's being the half of the boat is being hidden from this refraction zone. Look how big.
Here's the problem with that. Remember the image I shared a minute ago of the boat that we were using as a example?
Yeah, but that's different conditions, so I don't know if we should do that.
Wait, how do you know? Because I'm looking at your video right now.
Because there's no refraction in that image. That's how I know.
But you already said that even if it's cloudy, you don't know what causes it or what it will do on different days.
No, I said I don't know what the clouds have to do with it. That's what I said.
Okay, so better yet, then no. But if it's a cooler day, will we see refraction then?
You'll see some refraction, yes.
Okay, if it's 50 degrees outside.
I don't know. I don't know what the variables are that lead to more or less refraction, to be honest. I mean, obviously it can be temperature, but I don't know to what degree, you know. Well, is it 50 degrees or is it 30 degrees or is it 100 degrees? I'm just not, I don't know that.
There's actually goes both ways. So in a very, very, very clear day, in a very, very, very cold area, you'll get it. On a warm day where the air is warmer, or where the air is cooler than the sun's rays, you can get it on those days. So if it's a cloudy, cold day,
so what's
about 50 degrees.
What's the point of the question?
The point of the question is that 50 degrees on a cloudy day, you're not going to have refraction.
Okay, so what does that have to do with this image or video?
Well, for one, this won't happen on that day. That's step one.
Well, we don't know what the conditions were on this day.
Okay, well, you knew the conditions to tell me that it wasn't the same as the other one.
Yeah, because the other one, there's no mirroring in the other one, so we know the conditions weren't the same.
No, but see, that's what you're not understanding. You're
How am I not understanding it? Are you telling me that this, if we look at this picture and we look at the other picture, that of the boat sitting above the water, almost perfectly sitting above the water, no refraction, no mirroring, is the same as this? The same conditions?
Well, for one, this is really crappy quality. Two, it would matter on conditions, obviously, but you've already stated that you couldn't answer that question because you don't know the conditions. Because I remember I asked you in the other image, or I asked you what makes that happen and why doesn't it do it the way we would appear to, and you said, well, you couldn't say because you don't know the conditions.
Here, I'll pull it up.
Okay.
Do you see any mirroring, any refraction, or anything that would indicate these are the same conditions as the other one we're looking at?
Yes. Do you see under that boat? Do you see?
Yeah.
So wait. Because you don't see an image of that boat, there's no mirroring? How is that boat in the sky like that then? Because
the water line has been camouflaged, if you will, or mirage. I don't know.
Mirage.
To be higher than it appears.
Well, that would.
But this isn't the water line on the horizon. The water line is actually around here.
Well, that would be the whole point of an optical mirage.
Right, but the water is mirage. The boat doesn't have any miraging.
Okay, so you know that when this happens, it happens under the same situations as the other one, right? The only difference is this one isn't a video and it's clear.
No, he's got some still pictures. Here's a still picture.
Well, see, go back. Wherever you just were, go back to where it was a clear image. Yeah. Okay. When we're looking at this, we're seeing the mirroring effect.
Correct.
The thing is,
and this one we're not.
Okay. The thing is if you brought that boat closer to us.
This one or the other one?
The other one.
This one.
Yes.
Yes.
The mirroring effect would lower. It would lower till it was gone, till you didn't see it anymore.
Yeah, I agree with that. You're right. And as you go further away, it increases in size.
The reason it does that is because when you're observing that what is the apparent horizon that you don't see because of the mirroring, that's the light bouncing up. That's why you're seeing it that way.
It's not bouncing up. It's bouncing off the water.
Now, no. It's literally bending up. It's not bouncing off of anything.
Yes, it is. No. How is it bouncing up when it's a reflection of the top part of the boat?
Because it's not
it's bouncing down. It's bouncing down onto the water.
But it's because I can show you the illustration of exactly why it's doing it.
Okay, go ahead.
Again, it's not doing what you're thinking it's doing that way. The problem is, let me see which one. There you go. Oh, perfect. Okay, so I mean, this is on. It's on the YouTube page. Do you need me to share it? Or
yeah, go ahead and share it. Okay. I'll unshare somehow. Okay, good.
All right. All right, you should be able to see it. All right, so when we're looking at this image, it says it shows exactly what is happening. The reason
this hold on. This you're showing an example of a superior mirage. You know that, right?
Yes, but
and what we were just looking at is what's called an inferior mirage.
Yes, exactly. And this is also shows the refraction. So only reason I brought this one in is because it shows you where you're looking and why it's doing what it's doing, right?
Right. So in this example, you're right. In a superior mirage, a light refracts or reflects it up. That's not what we're looking at. We're looking at what's called an inferior mirage, where the light reflects down.
Yeah, and that's also, and I'm sorry because I completely skipped over it. That's why I was saying the two images couldn't be used, or can't be used. I'm sorry, can't be used.
What two images?
The boat one that we were watching from the video, and then the image.
Why can't it be used?
And then the image that we were looking at before with the boat with the clear bottom that looked like it was in the air, because that was a superior mirage, whereas in the other one wasn't. It was refraction or infraction. I'm sorry. I don't even think it was infraction. Hang on.
Infraction? I've never heard of infraction.
It is. Just hang on. I'll get it to you. I'll show you right now. Let's go to that document.
So let's just get on the same page. We're going a little bit off topic. So refraction can cause both a superior mirage, which is light bent up, and an inferior mirage, which is light bent down. Okay, it's the same cause, but a different effect depending again on different conditions. Both pictures actually show inferior mirage. The water is being reflected, on itself or whatever, but the boat just isn't. There's just no reflection or whatever of the boat. Hey, can you see if anybody else wants to join? I'm gonna have to go soon.
Yeah, no worries. Yeah, I wasn't using the link at all, so. Okay, so I'll put this link in our chat real quick, just so you can check this out, because this is like a whole guide on, not even a guide. It's basically just talks about atmospheric optics, everything about it.
Right. Sure.
Let's see, and try to get to the part where I was reading.
But so here's, and since I have to go, let me sort of finalize my point of view, or kind of finish up this point. So my point of view is the water is always flat and level from this side to the other side, right? No matter the distance. As you go further out, you experience more refraction that covers, quote unquote, more of the bottom. That's how we have the bottoms of buildings and the bottoms of ships appearing to disappear because of that inferior refracted mirage. Now, also, as the boat, if we're using a boat, goes further into the distance, it appears to shrink due to angular size, due to perspective, but at the same time, it's always on top of that water line. And then when it appears to disappear, it's just going out of view, out of range, due to atmospheric conditions, due to fog, haze. Even on a quote unquote sunny day, if you go to a certain distance, that boat will literally vanish because of the atmosphere. That's my story, and I'm sticking to it.
Okay, so here's what we're gonna do, because you said you had to go, and I personally, I think you would feel the same way. There's still a lot more to be said. Would you mind continuing this, some other time when you have time? No pressure on time, because sure, I know what's going on, so no, I'm not pressing you for shit. But it was a good combo. I do appreciate the time.
Yeah, definitely.
It's definitely a lot different when there's only two people and we're able to actually go back and forth.
Yeah, no, definitely. So I appreciate the time, and yeah, we'll do it again. Like I say, it's hard for me to join. I actually work from home on Wednesdays, so I have a little bit more time to join, I guess, or a few more open spots.
Yeah, no worries.
But I got to get off and figure out some for dinner and all that. So
yeah, no worries. You said it before. I know you got the family thing going on, so I'm not pressing you for time or when.
Yeah, no worries.
Just let me know.
Cool.
All right,
see you later, dude.
I appreciate it.
Bye.
Now, here's the one thing I'm going to say that I will not. This will not change as far as I'm concerned so far. The respect I have for Chris. Now, I know he's wrong. I'm trying, and again, guys, I'm learning too. So it may all these really obvious answers may have been out there, but obviously I may not know them. But I feel that I have enough knowledge in it, and I'm continuing with the research to have a good idea of what's happening, to determine whether or not it's something that we can say isn't curvature. Again, it's open panel, guys. If you guys feel that you understand it better than Chris did or better than I did, and you have a better explanation, let me know. Again, my explanations aren't going to be spot on. My explanations aren't professionally based, but I do have a basic understanding of it, so I feel like I can have this conversation. Obviously, I have holes to fill when it comes to answering a lot, but I would say that Chris does as well. But again, I want to make it like it was obvious to me when I first started seeing this, and I knew what I was looking at. When the boats are doing these things, please notice in any video you watch, when they're refracting and they're doing that mirroring effect, they do that from the bottom up as well, because it can only refract and mirror from what your eyes are seeing. So if it went over the curve that I know is there completely, it's not going to appear like it's still up there. Nothing that we see except for, that's why I wanted to bring in fog and haze and rain and cloud. I wanted to bring all those aspects into it, because what my point is that unless it's fog, which would seriously decrease your vision, your visibility, it's not going to, or everything else, any other condition, for the most part, isn't going to change that horizon. The horizon is the horizon. If that boat wasn't there, we would be able to find the horizon even easier. The problem is that there is something for that light to bounce off of that makes that effect. But it has that effect from the bottom as it rises up to the top. And then when it's not those conditions, we see a boat disappear from the bottom up all the time. Matter of fact, there's not a situation besides the fog maybe, or a really thick haze, that any object would just disappear in the distance, because it doesn't do that. There's no observations for that. That image, that video we were watching, I really hope in the time that we talk again, he comes with a much clearer image, because that was probably, to not use the image I have at the bottom left corner, but use that video and use it as good to go, because it kind of works with what you're saying. The problem is what you're describing, I don't think you understand how that works, because again, with a few days of fucking research, I know that regardless of the mirage that we're observing, it's still going to happen from the bottom up, and that happens because the bottom appears to be going over a curve, when in realistic, it's just the curvature of the Earth. I know that this is an issue and something he needs to look into, because again, in the beginning of the conversation, he used a theodolite as his reasoning for why he knows, where he doesn't have a grasp for how a theodolite works. So how could he use that as his evidence? And then his evidence is based behind that apparent horizon that theodolite in his brain thinks would have an effect. So is his whole hypothesis starting from a bad point? Because again, and I want to express this. This is very apparent. Like anyone can do this, and there's no one that's going to be able to tell me BS. Get your phones out, and I know you're not going to want to do this, but pay the $4.99 for the theodolite application, and go outside, go to the beach, go to the mountains, and use the theodolite. Learn how it works, because that theodolite is 100% evidence that there's a curve, and it is a curve that works how we describe it on a globe. There's no other way. And regardless of these little factors that you can add into it, it's not going to give you the same observation of what we see when a boat does start disappearing from the bottom up every time. Again, mirages aren't going to give you the exact same images. Mirages aren't going to give you a constant observational that you can use. The reason they're called atmospheric phenomenons is because they can explain what's happening, but why, no. How, definitely. They know cold air, warm air, surface temperatures, all that plays in a factor. But again, there's no time ever has all the atmosphere on Earth been the exact same within the conditions wise. But from the West Coast to the East Coast, to UK to Australia, to Japan, Russia, Alaska, it does not matter. The boat still will start disappearing from the bottom up at the same approximate distance relative to your elevation, obviously. But again, guys, no one's gonna jump on. It's all good. I'm hungry. I'm gonna go eat anyway. The main thing I wanted to talk about is what we went through today. Me nor Chris gave enough obvious evidence to tell you it's flat or globe. Correct. Even I see that. But if his idea of how refraction and or atmospheric optics works, period, isn't sound, then we know we got to back up. So hopefully he'll be able to get on soon again. But I have no problem. We'll do this again. It was a great conversation. It boggles my mind how anyone could think calling someone a fucking idiot and then wanting to have a debate or a conversation is going to work. I think me and Chris got a lot further than any other debate could have, because there's no BS in it. You don't need all that. That shit that happened yesterday, that's ridiculous. But again, that's here nor there into this rant. But I have another one. Guys, I'm going to get out of here. In regards to yesterday, again, I've had people even asking me still, no, Bro Sanchez did not snipe me off that panel. I lost my connection with the internet. So it ended my Hangout in my stream. Or it didn't end it, but I couldn't use it. I instantly got back on and restarted the stream. Obviously, you guys know that because you guys were here. No, Kurt, no, the Hangout's still open. You can still get in there. But yeah, no, I closed it out to the OBS though. I'm not in it anymore. But I lost connection. I sent him the link again that I was sending out already. The problem I got was I got the impression that basically he acted like I was on his panel and I jumped out or I ran. Bro Sanchez, man, I don't roll like that. Now, you may, because that tantrum you had just kind of seemed like a back out, but I'm not going to say it is for sure. I don't know. Maybe you had a bad day. But anytime we can finish that conversation, I have nothing but the utmost confidence that I'm correct. Not only, or I know I'm correct in the Corey Meteor situation, But my other claim about your channel, I think I'm right still. And if I have to prove it, I can. I mean, it was on my live stream, and I'll replay it over and over again so you can hear it. But you stated, and I quote, "My beliefs will not be changed by facts, or my facts." The problem is facts are facts, man. And if your beliefs can't be changed by facts, then you're running a narrative based on not truth. Let's get that? So anytime, Bro Sanchez, again, more than welcome to come on my panel. I have no problem going over to your channel either. But I'll say this, and I'll be very clear on this. I will not go on your panel if anyone else is there. One-on-one, just like I had it. I do that for a reason. And I will not go on your panel for the same reason. So one-on-one, I'll go over there, no problem. One-on-one, you're more than welcome here. It will be one-on-one. You can lie. I don't care if you dual stream it. I'd rather you not make it seem like I'm on your panel, and I'd rather you not advertise your super chats and all that stuff on my channel. But again, that's actually kind of petty, because regardless, they did add to your super chat and you did, yes. So I'll be wrong in that situation. I apologize on that one. But the tantrum part, that can't happen again. I was embarrassed for you. Like you were embarrassed because I said gravity. I was embarrassed because you acted like a child on a live stream. So step it up, man. And when you get those tears wiped up, you let me know, and we can do it again. But until then, man, study up.
But my legs heavy, I don't get it. How come I haven't hit it already? Still working, I'm still learning, I'm still searching, finally earning something, finally turning something called a profit. If I hear you talking shit, don't get caught in it. I'll be popping off and hit your ass, dropping all your shit. Yeah, I promise this, I got promises. You ain't stopping this, cross my shit, you'll be knocked unconscious, bitch. That's the consequence, I got this, I will not quit. Man, I'm on it, honest, I'm gonna launch quick, then I'm gone. It's just a matter of time before I'm over the climb and moving under my prime. Just quit my 9 to 5, I'm rocking, and they watching, cause it's shocking. Dropping all these top 10 songs, so stopping. It's time to live my life, it's time to live, not die. Wish